Okay, welcome back. We're now talking about using our intercepts to sketch the graph. If we have an equation where both the x and y's have an exponent of 1, positive 1, so no squares or anything like that, no variables in the denominator like we dealt with in Chapter 7, then we can talk about graphing those equations, because the graph will actually be the graph of a straight line. Now, we begin by finding our intercepts. So we've talked about that already. So remember to find the x-intercept. We go into the equation, replace y with 0. We then proceed to solve that equation for x. And so doing so, we get x is equal to 3. So meaning our x-intercept is the point 30. Likewise, for the y-intercept, we go into our equation, replace x with 0. And then solve that equation for y. And so doing so gives us y is equal to 4. So we have the point 0, 4. If at any point as you're going through these videos you need to pause it to kind of catch up or to kind of work things out on your own, I do encourage you to do that. So we now have both our x and our y intercepts that we've now found. So at this point, we want to plot those points on a graph. So we go to our axes, and now to graph our points, remember the x-intercept was the point 30. So we plot the point 30 on our graph. And the y-intercept was the point 0, so we plot that point on our graph. And then we draw the line that goes through those 2 points. Okay, and then that would be the graph of our equation. Okay, let's move on to another example. Consider the equation y equals negative 3x. So again, we want to find our intercepts. So for x, we replace y with 0. Get 0 equals negative 3x. Then we solve that equation by dividing both sides by negative 3. We find out x-intercept is 0, 0. For our y-intercept, we put 0 in for x. Alright, we find out that y has to be 0, so we have the point 0, 0. Oh boy, here we go again. Yes, we only have 1 point. Yes, Mr. Purple, we do need to have... Okay, that's enough. That's enough. Stop it. Purple and yellow, stop it. I can handle this. We're going to need another point. Because right now, we have one single point on our graph, because it happens that our x and y intercepts are both 0, 0. So we need another x or y value. And again, anytime you have an equation, if you know one of the values, you can always plug it in to get its matching pair value. So we can pick a value for either x or y. Since the equation was solved for y, I chose here to say, well, let's let x be 1. What would y be? Well, y is negative 3. And so we do have a second point, point 1 and negative 3. So at this point we have our point 0, 0 and our point 1 and negative 3. So we can now go to our graph and plot those 2 points. So we plot our point 0, 0. We plot our point 1 and negative 3. And then we draw the line that goes through those 2 points. Okay, and so we now have the graph of our equation. Now there are 2 special graphs or kinds of graphs that you do have to be concerned with, because they do work a little bit differently. You can't actually go through this process of finding intercepts first. You kind of get the intercepts after the fact. And those are equations that involve either just x or just y. So consider first the graph for x equals 2. The x value is fixed as 2. It must always be 2. Our equation, though, says nothing about y, so we can actually let y be anything that we want. So particularly we could say let it be 0, 1, and 2. And then we can draw our graph. There's our x value of 2, and then plot those 3 points. 2, 0, 2, 1, and 2, 2. And then draw the line that goes through those points. Now you only needed 2 points. I just did the third point to really kind of emphasize that it's always going to be 2. And so in fact actually get this vertical line. And so now we can see that it crosses the x-axis at 0, at 2, 0, and it never in fact crosses the y-axis. Okay, so that's a vertical line. And then if you have a y equation that just involves y, like y equals negative 3, again what that means is that the y values are always fixed as negative 3. Right. But our x values can change. So we can let x be anything at once. So particularly, we can let it be 0, 1, or 2. And again, we can draw our graph. Our y value again is fixed at negative 3, but x can be anything at once. And then we can plot those 3 points. Again, we only need 2 of them, but just 3 to make it really clear that y is always fixed at negative 3. So we can plot the point 0, negative 3, 1, negative 3, and 2, negative 3, and then we can draw the line that goes through those 3 points. And so we see that when y is equal to a fixed number, it's a horizontal line that goes through y equals negative 3. So my advice is when you encounter these, just do a quick table of values and plot points. You can, of course, remember, if you wish, that when it's x equal to a number, it's going to be a vertical line through that point. When it's y equal to a number, it's going to be a horizontal line through that point. And that would, of course, save you a little bit of time. But if you're not certain, plot some points and figure out what it is.